Hello, I'm Simon. Welcome back to the workshop. Now today I've got a little woodwork project that involves a little bit of electronics. But don't worry, I'll walk you through that. Any woodworker can do this. So let's get tinkering. Now I'm going to be using a piece of teak for this project, but you could use any wood, including softwood. This piece is just under 2 inches thick, that's about 50 millimeters. And the first thing I'm going to do is cut it to length on the table saw. As with all my projects, I'm using reclaimed wood. Now this does have a nail in one end, so I'm avoiding that end, and there's also a nail hole as well in the piece of wood that I'm going to be cutting off, but I don't think that hole is going to get in the way of the project. Now I have actually cut this a little bit longer than I need it, just so that I've got a little bit of wiggle room in my project. Now there are a few saw marks in the surface of this piece of wood, so I'm just going to give it a quick sand with 80 grit sandpaper. I decide that's too much like hard work and use the bench sander. I should really use a hand plane really. I should have just gone with my first thoughts. I don't know why I find the plane a bit intimidating, but when I use it, it always turns out okay, and it's always a lot quicker than sanding, and it's quieter and it's very satisfying. So I really don't understand why I always hesitate to use it. I probably just need to get more familiar with it. Now this is a 3D printed template that I want to draw around so that I know where to cut and where to drill. Now this template has fallen apart and I was going to use it as a router template and it's not going to be good enough, so I'm going to have to print another one and make it solid rather than having infill in it, which makes it hollow. But it'll be good enough to draw the shape that I need to start with. I recently visited a Art Deco museum in Norway, and this design is hopefully going to be a little bit Art Deco in style. I'm going to route a stepped oval in this piece of wood, but before I do that I'm going to remove a lot of the material just using a Forstner bit. This first one will be a little bit shallow, probably 7 or 8 millimeters, and then the second oval that I'm going to do will be a lot deeper. This second smaller Forstner bit should leave a little lip all the way around. It'll all need tidying up with a router later. I've set the depth of this one so that it doesn't go all the way through but goes through most of the material. So I'm now going to use the chisel just to tidy things up. Using double-sided tape, I fix a routing template to the workpiece. Now, many of my viewers might be new to electronics. I just want to explain what I'm doing here because it is very simple and doesn't require any prior knowledge really to understand and build. So this here is an LED matrix. You don't really need to know a lot about it other than it's got some pins here which need to be wired up to the pins on this thing. And this thing is a programmable microcontroller called an ESP32. And you don't need to know a great deal about this either, other than it's got a Wi-Fi module on it, and it's got a lot of different pins that we can use, and we can program it by plugging it into our computer and using the Arduino integrated development environment, which will allow us to take some code off of the internet, which will turn this into an internet clock. So basically what will happen, it will use the Wi-Fi to connect to my router. It will then talk to a time server to get the time, and it will then display the time on this module. Like I say, you don't need to know how any of that works because you just download it off of the internet, load it on. I've actually checked the code to make sure nothing malicious is happening, but most of this code is open source and therefore it's been reviewed by lots of other people. And then this here is simply a way of going from a micro USB slot to some pins so that I can power it, and I'll power it by connecting a jumper wire from these pins here onto the pins here. So we're not actually going to use this socket here at all. This is a little bit too big as it is, so I'm going to take off this part of it. I'm just going to desolder it, and then we just need some wires, and these wires are already prefabricated with the plugs on them, so there's very little to actually do. Now this is a little adapter from the normal USB to micro USB, and it had those pins are really designed to allow you to turn on and off the device that you've got connected between these two sets of sockets. I'm not actually going to use that functionality. I'm just going to tap off the 5 volts and ground. I wouldn't normally advocate cutting a circuit board in half, but this is a very simple one, and the bit I cut off was only the connections to that USB socket. It didn't have any other circuitry on it, so I was pretty confident that it would work, and I've tested it and it still does work. I now need to make a hole so that I can access that socket from the back to power the device. So I've chiseled out a groove to thin the back so that I could get this circuit board close enough to the outside so that when I plug the cable in, it engages properly. I've actually got the cable in and I've tested it, and I've put these couple of wires on here just to check that I'm actually getting the voltage from the cable through to these wires. Now with this cable in, I can then hot glue all this to hold it in place. I'm not going to do that just yet because I've still got some work that I need to do on the case. I've set my bandsaw table to an angle so that I can create a foot for this object to sit on, so that it points up slightly and is at a slight angle. Just think it'll look a bit nicer. Now to do that, I've decided that I want to use the wide part of the fence, which does mean I've got quite a lot of blade exposed, so I need to just be careful of that. I just think that's going to work better than the narrow piece of fence that I could have used. Just something to be aware of when you're doing this. I can now trim the end and then trim it to length using the table saw. The length of this foot is arbitrary really. I'm just doing what I think looks nice. I have a nice piece of veneer here that's nice and flat because I flattened it in my veneer storage dash flattening jig, and it's been in there for quite a few months now and it has come out really nice and flat. It may have been pretty flat when it went in. A lot of the wood wasn't particularly flat when it went in, so I don't know if this was one of those pieces or not. And it's just right. It's a good match for the rest of the piece. And I'm going to stick it down using double-sided tape to a piece of sacrificial ply. And then using double-sided tape again, I'll stick on the drilling guide. I now have 256 holes to drill. And if I get any of these wrong, then it's going to look a bit of a mess. But hopefully, with the drilling guide in place and the test that I did in a previous video, I'm reasonably confident that it'll work out okay. Although I never actually tested drilling 256 holes last time, I just did about 16, I think it was. So hopefully this will turn out okay. I could put this in my bench drill, but I think that it'll actually be quicker doing it by hand. And given that it's such a thin piece of veneer, I doubt if any slight angles are going to make much difference. Now I'm relying on you to make sure that I don't miss any. So shout or leave a comment if I do. Then I can go back to it before I finish this project. I then give it a light sanding. Some of the holes have joined up together when I started sanding it, and it's ruined. So I need to use a slightly thicker piece of wood. And these drill templates are only designed to be used once, so I'll have to print a new one of these. So this time I'm going to try making the fascia about 1/4 of an inch thick. That's 6mm, which would be about 3 times thicker than the veneer I was using. I first need to cut this board to length, and I'll then cut it to thickness. Well, that looks more dramatic than it actually was. I think it indicates that I need a new blade, which I've known for a while. I've just not got round to doing it. I wouldn't have seen so much smoke if I'd had the dust extraction on, which I also forgot to put on. I'll now cut this roughly to width. It's going to be a little bit wider than it needs to be because I want to plane it down so that it fits perfectly. I've used double-sided sticky tape again to glue this template to the piece. Just going to route the inside again just to clean it up a little bit more. It'll also make it slightly wider so that hopefully the parts will fit inside nicely. So here we go again, another 256 holes to drill. Now, did you see me make that mistake where I started drilling where there wasn't a hole? Now, I'm hoping I didn't actually get through the plastic, but I might have done. But I'm hoping that I didn't and that it's all okay. If not, I'll either have to fill it or start all over again. Often when I get to this part of the build, I start thinking about the people that may be watching this video. Are they enjoying it? Will they subscribe? Will they share the video with others? It'd be really difficult to know if your videos are enjoyed by people if no one clicks that thumbs up or doesn't leave a comment to say they enjoyed it. So here's that mistake I made. I'm going to make this the back, and hopefully this hasn't gone all the way through. To help with the alignment, I'm going to add a little chamfer to the back of each of these holes. This will just make the light guides work a little bit better if there's a little misalignment of the LEDs. Now I do have some plastic light guides from a previous project that I could use, but I don't really fancy having to cut out 256 light guides, get them all nice and square, put them in and glue them. I'm just going to go for filling these with hot glue to make my own light guides. I have never done this before, so I'm sort of making it up as I go along, but hopefully it'll work. And I'll fill the light guides from both sides. So I've realised a couple of things that are just worth going over. I was going to use this little socket here with the breakout for the power, but I realised that it would be more convenient to actually have a data signal into this ESP if I ever need to reprogram it, and therefore just taking the data off is not going to be good enough. So I've ordered a little breakout box, which is a micro USB to little pinouts, which will then allow me to connect to the ESP32 via the USB in here. And that'll mean that I can reprogram it at any time just by plugging the clock into my computer rather than just into a charger. The other thing that I realised was that I don't really have enough room with these two bits here if I keep these on these connectors. So I've got some wires here and I'm going to solder these all on separately, and that'll make the whole thing a lot neater and a lot smaller, and that'll give me plenty of space inside. So this is a lot thinner now. I've taken away the connectors and soldering them on, and I've double-sided taped to the back of the LED matrix module. That makes for quite a neat thing. I've checked it with a battery and I've connected it to my computer, so I know it all works fine. So now I just need to wire up the USB on the ESP32 to the USB at the back of the case. Now this might seem particularly dim, but it's for a bedside clock, and I don't like clocks that give out too much light. It is controllable in terms of how bright it is, and this is on its dimmest. What I now need to do is just align the fascia matrix with the LED matrix underneath and then fix it in place with some hot glue. I'm now ready to add the finish, and the finish that I prefer is Danish oil, and I use it for most of my projects. This will take a few coats to get a nice sheen, but it really does bring out the luxury of this sort of wood. And it's in keeping with the Art Deco styling that I'm looking for. Now obviously this is a bit of a mismatch of 21st century electronics and Art Deco design. I'm hoping that when I put it all together it does actually look really smashing. Assembly was a simple matter of sliding the fascia into the case. So what do you think? Was this worth building? Was it worth all the aggravation to get it right? I'm pretty happy with it, but I'll be interested in your views. Let me know in the comments. If you've enjoyed this video, then please remember to subscribe. It's completely free. And I'll see you in the next video. Thanks for watching.